In the above question, what is the collector voltage? 3 volt. The purpose of resistance in the emitter circuit of a transistor amplifier is to limit the change in emitter current. The base resistor method is generally used in switching circuits. In a base resistor method, if the value of beta changed by 50, then collector current will be changed by a factor 50. If the value of collector current IC increases, then the value of VCE decreases. In a particular biasing circuit, the values of RE is about 8 ohm. The value of VBE is almost independent of IC. A silicon transistor is biased with base resistor method if beta is equal to so VBE is equal to 0.7 volt, zero signal collector current IC is equal to 1 milliampere and VCC is equal to 6 volt. What is the value of the base circuit or resistor RB? 0.30 kilo ohm. When the temperature changes, the operating point is shifted due to change in ICVO. The stabilization of operating point in potential divider method is provided by RE consideration. In the design of a biasing circuit, the value of collector loads RC is determined by VCE consideration. For a germanium transistor amplifier, VCE should not fall below 0.7 volt for faithful amplification. In a transistor amplifier circuit, VCE is equal to VCB plus VBE. The stability factor of a collector feedback bias circuit is less than that of base resistor bias. If the temperature increases, the value of VCE is decreased. The value of stability factor for a base resistor bias is beta plus 1. In voltage divider bias, VCC is equal to 25 volt, R1 is equal to 10 kilo ohm, R2 is equal to 2.2 V, RC is equal to 3.6 volt, and R is equal to 1.1 kilo 1 K. What is the emitter voltage at volt? In voltage divider bias, operating opposite point in 3 is 3 volt, 2 milliampere. If VCC is equal to 9 volt, RC is equal to 2.2 kilo. What is the value of RE? Also, the disadvantage of voltage divider bias is that it has many resistors. For proper amplification by a transistor circuit, the operating point should be located at the middle of the DC load line. The thermal runaway occurs when transistor is not biased. The operating point on the AC load line also line. The operating point is also called the quiescent point. For good stabilization in voltage divider bias, the current I1 flowing through R1 and R2 should be equal to or greater than 10 IB. The disadvantage of base resistor method of transistor biasing is that it is sensitive to change in beta. An ideal value of stability factor is 200. The leakage current in a silicon transistor is about 1000. The leakage current in the germanium transistor. The biasing factor. The biasing circuit has a stability factor of 50. If due to temperature change ICPO change by 1 microampere, then IC will change by 50 microampere. If the maximum collector current due to signal alone is 3 milliampere, then zero signal collector current should be at least equal to 3 milliampere. The circuit that provides the best stabilization of operating point is potential divider bias. Transistor biasing is generally provided by biasing circuit. Transistor biasing is done to keep proper direct current in the circuit. For the faithful amplification by a transistor circuit, the value of VBE should not fall below 0.7 volt per silicon transistor. The zero signal IC is generally 1 milliampere in the initial stage of a transistor amplifier. The point of intersection of DC and AC load line represents operating point. For faithful amplification by a transistor circuit, this value of VCE should not fall below 1 volt for silicon transistor. Operating point represents zero signal values of IC and VCE. Transistor biasing represents DC condition. For power operation of the transistor, its collector should have proper reverse bias. If biasing is not done in an amplifier circuit, it results in unfaithful amplification.